This is the ninth video on the short course of effective data collection. In our previous video, we did look at open-ended questions and also closed-ended questions. In this video, we shall be looking at sampling your population. My name is Douglas Amenya. I research at DataTrax Research Limited. This short course has been funded by DataTrax Research Limited. Ideally, a survey should gather data on every single person in the target population. Collecting data on everyone in the target population is the best case scenario, since it ensures that everybody who matters to the survey is represented accurately. However, this is only possible if the population is small enough and the researchers have sufficient resources to reach out to everyone. This is not often the case, so researchers have to identify a subset of the population to survey. How you choose this subset of the target population that is crucial to the quality of your data is very important. This group must be carefully identical and representative of the larger population, else your data will not be useful for drawing inferences. If done right, survey sampling can save time and money while allowing you to draw inferences about a larger group of people. We consider these three key things in mind while choosing a sample population: consistency, diversity, and also transparency. So choosing your sampling technique, we have two sampling techniques. That is the probability sampling techniques and also the non-probability sampling techniques. Now for the probability sampling techniques, each person in the population has a defined non-zero probability of being included in the sample. Probability sampling provides the most valid or credible results because it reflects the characteristics of the population from which they were selected. There are three probability sampling methods. We have random sampling, we have systematic sampling, and also stratified sampling. Now, for the non-probability sampling technique, the sample is constructed with no probability structure. The selection is not randomized, so the resulting sample is not fully representative of the target population. There are three main non-probability sampling methods. That is the convenience sampling, snowball sampling, and also the quarter sampling. So how do you minimize the sampling error? There is one easy way to minimize the sampling error. That is to increase the sample population size. The more respondents you have, the more accurate your survey will be. However, it is not always possible to increase the sample population because of the financial implications. So we seek to avoid these three common errors as much as possible, for they will help us to minimize the sampling error without increasing the sample size. 1. Avoid population specification errors. 2. Avoid sample frame error. And 3. Avoid non-response error. Let's look at the first one. Avoid population specification errors. A population specification error occurs when a critical segment of the population is not included in the sample. And this is the result of a knowledge problem or gap. The results of a survey with a population specification error will shed some light into the issue, but they cannot provide the full picture. Let's look at the second one, which is avoid sample frame error. Now, sample frame error occurs when a survey samples the wrong segment of the total population, usually because the surveyor has missed a new trend or change in their target population. And the third one is avoid non-response error. It is normal for some targeted respondents not to respond to a survey. However, this can become a problem if the non-respondents generally hold a view that is different from the respondents. As a result, the final data will be skewed towards the opinion of those who responded or who took part in the survey. So then how are we going to calculate our sample size? Determining the size of your sample population is one of the most difficult decisions to make in your survey. A large sample can yield more accurate results, but the more respondents you collect, the more expensive it gets. So let's look at these two statistical variables which we use to calculate the sample size. One, it is the margin of error, and two, the confidence interval. Let's begin with the margin of error. So no sample will be perfect, so you need to decide how much error you are willing to allow. The margin of error determines how much variance you want to allow in your data. Let's take an example. If you set a margin of error of 5% and find that 68% of women take iron pills, then that means that the real percentage of women who take pills is between 63% and 73%. How do we arrive at this one? We add or subtract 5% to 68%. The confidence interval. How confident do you want to be that your actual number falls within your margin of error? Okay, the most common confidence intervals that we use are 90%, 95%, and also 99%, which correspond to the z-scores which are given in that table. So for example, imagine that you set a margin of error of 2% and a confidence interval of 95%. Then you find that 68% of women take iron pills. You can be 95% confident that the true number of women who take iron pills is between 68 and 70%. And how do we arrive at this one? We just add or subtract 5%. Now, when calculating the sample size, usually you can calculate the sample size of a population that is known or of a population that is not known. And when we say not known, that is the size is not known or the size is known. So how do we go about this? Let's begin with the sample size formula for a population that is not known. So often, a population is too large to easily measure. When we have a case such as this, then we use a sample size formula that does not account the size of the large population that you are surveying. The sample size formula, when you don't know the size of your large population, is usually n, whereby n is the sample size, and then we have the z-score, which is represented by that, and then so that is the z-score squared divided by 4 m squared, whereby our m is the margin of error. This is for the population size that is not known. For one that is known, we make some few changes, and so we add the size of the population because now it is known by P, and then we have this formula as shown. In our next video, we shall be doing a final video, which is the conclusion. My name is Douglas Amenya. See you then.